The concept of black hole and dark matter has been intriguing scientists for a very long time. Due to the lack of technology, scientists and researchers did not get very far with positive results in this regard. But with the James Webb Telescope that we currently have, we have been able to derive observations that we weren't able to do for quite a long span of time. Hello guys and welcome back to our channel. In today's video, we shall be taking a look at Stephen Hawking's dark matter theory and its recent updates. Stephen Hawking is a cosmologist, physicist, and author who has gained massive recognition in the fields of physics and space exploration. The theories that he has come up with are mind-blowing, and quite a few researchers keep studying his theories and try to find evidence to back his theories up. We all know what matter is, and Stephen Hawking divided matter into two types: normal matter and dark matter. Normal matter is what we can see, such as planets, galaxies, and everything around us. As for dark matter, it is something that's quite an enigmatic part of the world that many believe occupies 1/4 of everything found in the universe. With NASA using their latest James Webb Telescope, they quite recently came across quite a magnificent find. This find was an infrared bright dwarf galaxy they were pretty shocked to find. If you're wondering why they were shocked, well, that is because this galaxy was found amidst older dying galaxies, and they did not expect to find a younger galaxy amongst them. There have been quite a few other researchers and scientists from centuries ago who have put out their theories about the stars and galaxies. One such astronomer is Albert Michelson. In the year 1884, this astronomer tried to detect motion of stars in the sky. He did so using a long-split spectrograph, which is used to record its light. The light is then made to pass through an instrument known as an interferometer, which helped him understand the Doppler shift. The Doppler shift is usually characterized by the rotation of the Earth. Unfortunately, his efforts went in vain as no change in the wavelength was detected. But according to other researchers, objects or matter that can emit and absorb light also have the potential to move while showcasing a change in its wavelength. But as we mentioned earlier, this shift in wavelength was not observed in Albert's experiments. Thus, the conclusion drawn out was that nothing moves in space in a straight line other than what is backed up by gravity. Speaking of gravity, gravity is found all across space and it travels at a constant speed no matter what the time or area of space it is in. But there have been occurrences where matter that cannot be seen has showcased some gravitational force to act on it. Nothing about this type of matter is clear at the moment, and the big question that is on the mind of all scientists is there something out there in the universe that could help measure space? The answer to this question at this point in time is unknown, but hopefully with the advancement in technology, we may come to know the truth and would also come to know if Stephen Hawking's theories were true or not. Stephen Hawking is one of the smartest men on planet Earth, and the theories that came up with, backed up by logic, have intrigued many in the field of space exploration. One of the most famous theories of Stephen Hawking is his dark matter theory. Stephen Hawking has spoken and written a lot about dark matter and dark energy. According to him, dark matter and dark energy aren't exactly forces nor particles, but are considered to be a characteristic property of space-time. Just taking a look at our solar system, we can easily say that gravity and planets are dependent on each other. The same applies to other heavenly bodies found in space as well. But there was a time that planets did not exist, but however, gravity was still there. So this means that there was something out there that existed due to which gravity existed. Back to dark matter. It is said to be an entity that can interact with normal matter with gravity as an intermediary. However, dark matter doesn't absorb or emit light or any type of radiation. There have been a variety of models of dark matter that have been drawn out, but the most promising one of the lot shows that they are weak particles that can only be detected by their gravitational force or movements that are caused by their effect in ordinary matter. This cannot be observed by us directly. The energy that's caused by this interaction is said to cause the universe to expand at an astronomical rate. This has also made it quite hard to understand and study the vastness of the universe. The James Webb Telescope, which was launched in 2019, is one of the largest infrared telescopes on planet Earth. This telescope was recently able to capture a class of new stars that other telescopes were not able to detect. As of now, this telescope is being used to detect everything that's around the Sun. Unlike other telescopes, the James Webb Telescope uses the aid of infrared light to understand dark matter and dark energy to a greater depth. As far as theories and basic evidence are concerned, more than 95% of all the matter in the universe is made up of dark matter. It's also important to note that it takes a longer time for infrared light to pass through space. This gives it more time to identify what's in its path. Furthermore, this telescope comes with a primary mirror that's made up of beryllium and is coated in gold. The main purpose of the gold coating is to reflect the infrared light very efficiently, which will in turn detect objects that are found in space. This telescope comes with three main instruments, namely the NIRCam, or the Near Infrared Camera, WFIRST, or the Wide Field Infrared Survey Telescope, and finally the FGS, or the Fine Guidance Sensor. Stephen Hawking was a genius in his own and had many of his findings based on the finds of another physicist, Paul Charles William Davis. Paul had stated that it could be possible that dark matter is made up of nuclear fusion particles that could have a mass of 3 to 4 times that of normal atoms. Furthermore, they would emit particles that could be detected from Earth. A while ago, they found out that quark-gluon plasma is the particle that's said to make up dark matter. The nature of this particle is quite unique, and it's also said that these particles are the reason why galaxies rotate faster at their edges as opposed to their center. This also happens to be why galaxies are moving far away from each other, including our own galaxy. Another researcher, Peter Willinger, stated that galaxies are influenced by dark matter. The theory of his and his team was drawn out based on their findings of theirs of a distant galaxy. This galaxy was studied using the famous Hubble Space Telescope. On accumulating all the results that were found by various scientists and researchers, galaxies are moving far away from each other faster than we anticipated. It cannot be gravity in this case, and many believe it's dark matter causing these phenomena to take place. It's also important to note that dark matter doesn't interact with electromagnetic forces, and they seem to exist because of the gravitational force that it has in normal matter. Another plausible theory that many experts in this field have come up with includes dark matter being constituted of pseudo-atoms. Pseudo-atoms function quite similarly to how normal atoms function, but they don't react to gravity, radiation, or any form of electromagnetic activity. In fact, there are so many theories in dark matter that some even believe that there are multiple forms of dark matter. Stephen Hawking's theory seems to make the most sense so far. He has stated that dark matter could be made up of neutrinos. He has also had a lot to say about black holes. Black holes are dense regions that trap light and any radiation in it. The gravity force here is quite strong, and they're said to be formed when old stars end their lives in collapse, ceasing to exist. But quite recently, it has been found that black holes have been formed by the extra matter that forms a large mass of gas that collapses due to its intense weight. Older galaxies tend to have a lower number of black holes, and thus, the concept of black holes can be studied only from new galaxies. Thus, the hunt for new galaxies is always alive. Testing these theories in laboratories is highly impossible, but NASA is always on the go to test these theories in space directly. And that's all for today, and we hope you enjoyed our video. Drop this video a like, subscribe to our channel, and turn on your post notifications to receive the latest updates from our channel. Bye and see you soon.